Chapter 4, selections. This is going to be fun, all about if statements, if else, nested if else, a lot to cover. Here's a brief overview of the objectives, which I won't even go through. Let's jump right to an example. Starting by revisiting a problem we've covered previously, which is the area of a circle. We want to be calculating, given a radius, compute the area of a circle. And so let's revisit the problem-solving phase and the solution that we came up with previously. So the algorithm is we need to get the radius from the user. We need to, of course, remember the equation for the area of a circle, pi r squared. We talked about constants. So even though Python does not have constants officially, we want to capitalize that variable pi that we're going to store 3.14 inside, for example. And then we want to compute the area and display the result. So this is an implementation that we saw previously. And so I want to come back over here to Thani. Let me go to File, New, Save, and let's just call this Area Circle version 2, because we're going to edit this. So I'm going to type this, even though we just saw it. Constants. Here we have pi equals 3.14159. We need to get the radius from the user. So radius equals int input. Please enter a value for the radius, right? And then we need to compute the area. Area equals pi times radius times radius. Pretty straightforward. And then finally print the results, and however you'd like to word this, the area of a circle with radius, for example, let's say it was radius 10 is, and that would have been, what, 10 is going to be, 10 squared is 100, times 3.14, that'd be 314, let's say 0.16. That's what we would like to print. The area of a circle with radius 10 is that. And let's put a period since it is a sentence. So this is a reminder of formatted printing. So if we want to do formatted printing, I always tell students, print the sentence that you would like, then simply add afterwards a dot format with parentheses, and ask yourself, within this sentence, which of these things are coming from variables? And in fact, we have two values. This is a value here, 10, and this is a value here, the area. Those both come from variables in the program. What are the variables? Radius and area in that order. This is the radius, and this is the area. So we simply put those variables inside the format function, and then replace those values within the sentence with a pair of placeholders, as you see. That's all we have to do, and I can run it. Please enter a value. Let's say we put 10, and it's going to have 3 digits after the decimal. No problem, but what if we had said 2 digits after the decimal? We would put :.2f, and we run it again. Let's put 10 again. 10 is the radius. The area of a circle with radius 10 is 314.16. Perfect. That's exactly what we're looking for. And just to make it complete, may as well put the formatting here, at least put :D for integer, since radius is an integer. One more time, 10, that worked. Try it with a different set of numbers, 15, that worked. Perfect. So this is the solution we've seen previously. So now the question, but what happens if the user enters a negative value for the radius? So if we run this, they enter 0, well, the area of a circle with a radius of 0, of course, is 0, right? But what if they enter a negative value? Negative 10. There is no negative radius, but if they did enter a negative value, that would give us 314.16 as an area, which makes no sense. And I say confusing, but it's not really confusing, because when you take a negative radius times a negative radius, that'll give you a positive number. And that's not what we're looking for, right? So if the user happens to enter a negative number for the radius, that's a problem. What can we do with that? And this is just an introduction to what we're going to talk about with this particular video. And what we're going to do with that is we're going to use an if-else statement to address that problem. That would be negative, that'd be a negative number. It shouldn't give you a negative area. It gives us a positive area, not what we want. We solve this with selection statements, which is this if-else statement. So we can use selection statements in Python, really in most programming languages, To choose one action or another action, to choose to go down one pathway or to go down another pathway, different alternatives. So here I'm going to go right to the code, and you see that all we did is we put in this if statement, which I like to go do up here. So I'm going to put an if statement. If. What is the if statement? Well, if, or let me put a comment. If the radius is, which we can choose to do the valid radius first and then print the error if it's not valid, or we can do, if it's invalid, print the area, and then if it's invalid, print the error message, and then afterwards we could print the area. I'm going to do reverse of what we showed here. So because I want to show you both options. So here, what if the radius is greater or equal, if the radius is greater or equal to 0, meaning it's a valid radius. It is a valid radius. It's not negative. So I'm going to say if radius greater equal 0. What am I going to do? I'm going to do all of this stuff. I'm going to put that, I'm going to tab it over. I highlighted it, and then I hit tab. And then here, I'm going to say else. In the meaning of else, I'll comment it. Else, if the radius is negative, negative would be invalid, right? If it's negative, it is invalid. And I'll put an empty blank space just for reading purposes. Else, if it's invalid, we'll print that same error message. Error, incorrect input for value, incorrect input value for radius was given. I'll say error, radius value must be 0 or greater than 0. Something like that. I could have worded that better, right? But that's our code. So let's run this now. When we run it, enter a value for radius, they enter 5, all is well. They enter 10, all is well. Someone enters 0, all is well. But when they enter a negative number, error, radius value must be 0 or greater than 0. And so this is how we can now have different pathways through our program. This idea of using an if statement, and even here we used an else statement in case that if statement was not correct. And this is intended at the moment as just a bird's eye view, like a trailer for the movie to come. This is not even going into the fine details, yet I bet many viewers will immediately already be like, I get that. That's not that bad. In fact, it's not that bad. That's why Python is beautiful, because it's so easy to understand. So that's the trailer. Now let's get into some of the nuts and bolts, if you will. A Boolean type, their values, and Boolean expressions that we can write. So how do you compare values in Python? As we just did here, we compared radius to 0. We compared radius, is it less than 0? Or on the code I made, is the radius greater or equal to 0? How do we compare two values in Python? And the answer is Python gives us 6 comparison operators. And if you look right here at this column, this will be our comfort zone, because this brings us back to maybe, what is it, 3rd grade, 4th grade, 2nd grade. These are mathematical symbols, right? We know these, less than, equals, greater equals, or equal to, or not equal to, right? These are the mathematical operators. Now, some of those operators you can do directly, you can type directly with a keyboard, such as the less than. Well, it's just simply less than, which is shift comma. Or the greater than is simply greater than, which is a shift period, right? But what about less than equal? If you look at your keyboard, I don't have a less than equal. So how do you actually type that in code? You literally put back to back a less than sign followed by an equal. Or the greater equal, you put a greater than sign immediately followed by an equal. If I were to put a space here and then run that code, Python is in a competent attitude and starts shouting at me in red, right? It's not happy with me. It needs to be greater, equal, right next to each other with no space between. Now, what about equality? Equality, to check in mathematics if something equal is one equal sign, but we know in programming, what is one equal sign? It's an assignment operator. We assign, right? We take whatever is on the right side, x equals 4, we take this 4 and we assign it into the variable x. We save that into the variable x. And we've talked about that it's really more nuanced than that, and we'll cover those nuances later. But for our purposes, for now, it's sufficient to say we save 4 or we assign 4 into the variable x. So that's assignment. So how do you check if two things are equal? In programming, and this is not just Python, it's almost universally accepted, in programming languages, you put two equal signs back to back. And that's how you can check if two values are equal. And then finally, not equals. This is kind of funky at first, certainly strange. You put an exclamation point followed by the equal sign. And so some examples we'll go through. That's talking about an assignment, but here I want to look right to this radius example. We say radius is 1, and then we want to print radius, for example, equals true. So how about if I say x equals 4, and then print x equal, or how about if I want to print x equal 5? Does x equal 5? And we should expect that that is going to print absolutely false. What if I print x equal 4? Yeah, that should be true. That's going to print true. What about if I print x, is it greater than 3? Of course, 4 is greater than 3. That'll print true. What about x, is x less than 8? Yeah, 4 is less than 8. That'll be true. What about is x less than 2? Is 4 less than 2? No, that's going to be false, right? Pretty straightforward. We did equals. What about not equal? So x, does it equal 4? That'll be true. And if we say it doesn't equal 5, that'll be false, right? What if I say not equal? If I say x does not equal 5, 4, just plug in what x is. 4 does not equal 5. That's a true statement. 4 does not, in fact, equal 5. And finally, if I said 4 does not equal 4, you're thinking, no, 4 does equal 4. So the statement 4 does not equal 4, that is a false statement. So here, how do we compare values? Is we can use those 6 comparison operators that we just showed you on this table, and we can use those operators to compare values in Python. Now, the result of a comparison is called a Boolean value. A Boolean value is either going to be true or false. It's one of those two options, either true or false. And so going over this example, radius equals 1. And here, if I print radius equal 1, that should have been not true. Radius equal 1, that will print true, because in fact, radius is 1. That's a typo here. Is the radius greater than 0? Yeah, 1 is greater than 0. That will also print true. This right here, radius equal, that should be 1, or radius greater than 0, those are called Boolean expressions. A Boolean expression is an expression where you need to compare two values using that comparison operator, and the result of that comparison is true or false. That entire expression is called a Boolean expression, and it will ultimately evaluate to true or to false. What is a Boolean variable? It's a variable that contains strictly a Boolean value. So here's an example. What if we wanted to have a variable called lights on that contained a Boolean value true or false to indicate whether or not maybe the lights were on in a room? And you could imagine a mobile application where you're holding your phone and you say, hey, let me turn off my light. Well, under the hood, that variable might just be lights on equals true, lights on equals false. And you're setting that value, you're assigning that value of true or false into the variable. So I can absolutely say, how about lights on equals true, and it has to be a capital T. So then I can print the variable lights on. Just wanted to print the value. And when I print it, it will show that it is in fact true. So we can save this Boolean value into the variable in the same way that we can save a number into a variable, or in the same way that we can save a name into a variable, right? So we can also save a Boolean value into a variable. So this is just a quick little slide just to tell you that, internally Python uses 1 to represent true and it uses 0 to represent false. It's not something we're going to be really seeing much of, but something you should be aware of. And so as a result, if you were to convert or cast this Boolean value true to an integer and then print it, it would print 1. And if you casted false to an integer, it would print 0. Kind of weird. Something you don't really need to, you should be aware of, but you're not going to be probably using much of within this content. So we're about to solve a problem, but before solving the problem, we need to know how to generate random numbers, which is new for us, but it's going to be super easy. How do we generate a random number? Python actually gives us this function, randint. And remember, we've seen a lot of functions. We've seen the print function, the int function, the eval function, the float function. We've seen a variety of functions, even some math functions, right? So we've seen ceil, min, max, floor, ABS for absolute value. We've seen a variety of functions. And here's just another function. Remember, how do you know that something's a function? Parentheses. If you see a pair of parentheses, it doesn't matter what's inside there. If you just see this followed by parentheses, you're like, that's a function. You don't know what it's doing, but it's a function. Well, guess what? Python gives us a randint function. And this function allows us to generate a random integer between those two values that you see there, A and B, inclusive of those two values. And this function is actually found within the random module. So we need to actually import random before we can use it. So for example, if I were to type in, here's chapter 4 notes. If I were to type in print randint, how about 1, 5, to get a random number between 1 and 5. If I run that, randint is a built-in function to generate a number. Let me be clear. Randint is a function to generate a number between A and B. So let me put here A and B. Inclusive, so including both endpoints A and B. But when I run this code, we're going to see Python says randint is not defined. It doesn't understand what randint is. Well, what did I say? We have to actually import random because randint is a function found within the random module. What is that random module? Think of it as a collection of functions that we're importing. So these are functions that Python has built in and Python can use for us, but before we can use them, we have to import. So we import random, but even now when you run it, Python still says it's not defined because you have to come right here and tell, yes, Python, I know, you're being so difficult. You're being difficult, Python. You have to come type random dot. You have to tell Python, where is this function located? You're telling it it's located inside the random module that you're importing. And then finally, when you hit run, guess what? It prints 3. Let's run it again. It prints 2. Run it again. It prints 2 again. We run it again. It prints 4. Run it again. It prints 3. We got 5. Let's do it till we get a 1. I'm running. I'm going to keep going till it gets a 1. I hope this won't be a long video. Okay, now I'm going to go faster. Finally, we got a 1. Okay, so it's just a random number generator. You can put any two numbers here. 30 to 80. Inclusive. Find a random number between 30 and 80. 55, 80, 34, 54, 39, 62. Am I going to get a 20-something? Oh, of course not. It's from 30 to 80. That's that right there. I was literally waiting. I was waiting for a 20-something. I was like, where is the 20-something coming? That is a big brain moment. And it's 30 to 80. So we get the idea, right? This is how we can generate random numbers. So random.randint from 30 to 80. So with that in mind, let's do program 1 of this chapter, which is a math learning tool. Write a program to help a first grader practice addition. Your program should randomly generate 2 integer values between 1 and 9 inclusive. You should ask the user for the answer to the addition of those 2 values, and then you should print true or false next to the result. Now, we haven't officially looked at if-else. We saw the trailer where I showed you if-else. We haven't officially looked at it. So we won't use if-else just yet because we haven't seen it officially. So let's not use if-else. Let's just try to use the Boolean values and those Boolean expressions. And we want to print true or false next to their answer. So always we have the problem solving phase before we do implementation. So problem solving is what? Generate those two random numbers. So num1 and num2, we're going to, for both variables, we're going to save into those variables a random number. So let's actually type up some of this. I'll go to File, New, Save, and let's call this Math Tool. Math Learning Tool version 1, because we're going to make mini versions. So step 1 is we need to import random, because we'll be using random. That's like step 0. Step 1 is we need to generate two random numbers. Step 2 is what? I'm going to come back to the description. Ask the user to answer the addition of those two values. Prompt the user to answer an addition question, those two values. Step 3 is, I'll put step 2 and 3 together really. Step 2, prompt user to answer an addition question, and then even and scan their answer. Let me zoom in a bit for you. Prompt the user to answer an addition question and scan their answer. And then step 3, print the results. Always, where we want to get something, compute something, and then print something is what we've been doing. But now it's going to finally change a little bit. So now we're generating something, kind of like getting something, getting some data. Prompt the user to answer a question and then scan that answer and then print the results based off of now this Boolean expression that we're going to write. So let's see how we would actually do this. So in problem solving phase, we know that we need to use random.randint. Ask the user to answer what is, for example, 4 plus 5, and then simply check if it's correct or incorrect. So here are some samples. What is blank plus blank? What is 1 plus 7? The user enters 8. We print 1 plus 7 equals 8 is true. What is 4 plus 8? The user enters 9, and we should print 4 plus 8 equals 9 is false. We want our program to work exactly like that. So first thing is generate two numbers. Num1 equals random.randint 1, 9. That's not that bad. You don't want to type. If you type a little slower, that's fine. Copy paste is your friend. And this is num2. Done. Prompt the user to answer an addition question. So how about we're going to call this user answer equals, and we want to scan the user's answer. So user answer equals int input. And here inside input is where we want to ask them to, we'd say enter your answer, for example, right? But we're not going to even ask them enter their answer. We're just going to ask them the question directly right there. So really, we're going to ultimately use formatted printing, and it's not printing. I mean, it is printing, but it's formatting within the input, which is allowed. What did I say we want to normally do is just simply type hard code exactly what you'd like to print. So I'm going to type in, what is 1 plus 7 question mark space? What is 1 plus 7 question mark space? That's what I would like to get printed. But this 1 and this 7, as we know, should be coming from this variable num1 and num2 that we randomly generated. So here I'm going to put, like a normal print statement, I'm going to put dot format, then I'm going to put a pair of parentheses, and right here I'm going to type in num1, num2. And then I simply go back to my string and I say, here's my entire string, where is num1 coming from? Right here, put a placeholder. Where's num2 coming from? Right there, put a placeholder. It's that simple. And now we want to print the results. So there's many ways you can do this, but we have a user answer. We need to check if the user's answer is the same as the correct answer. So you could also say, how about correct answer equals num1 plus num2. So we're taking, remember this is an assignment, we're taking num1 and num2, we're adding them together, and we're saving that result inside correct answer. And so we need to print this statement, 4 plus 8 equals their answer is false. This is going to be funky, but we're going to do this with formatted printing. So check this out. Print the entire statement hard-coded. So print exactly, no, let's do the 1 plus 7. So 1 plus 7 equals 8 is true. That's what we want to print, but we want that to come from variables. We don't want to type in a 1 here and a 7 here and an 8 here and true here because we don't know what those values are because they came from randomly generated values. They came from the user's answer, right? So we can't just type in a 1, a 7, and an 8. But I always say type that directly first, then put a dot format, then put a pair of parentheses. And how many things is it? How many placeholders or how many things are you going to need within this string? Well, this comes from the variable num1. This comes from number 2. This is the user's answer, which happens to be the correct answer as well. And the reason you know it's the user's answer because even here when they entered the wrong answer, we put the 9. So that's the user's answer. And then here is a true or a false to indicate whether or not the user's answer equals the correct answer. So we have 4 things, and let's type them, those variables, here within the format. So what comes first? Num1, num2, user answer. And then what comes here? What is this last thing? So let's go through this. This is your first placeholder. That's num1. This is your num2. This is your user answer. And then this is a placeholder. What needs to come right here should be a true or a false. It should be a true or a false. And how do we get a true or a false? What can I put here? Remember, a true or a false is the result of comparing 2 things in this example. Comparing 2 things, we can get a true or a false. Well, what do we want to compare here? I would like to compare the user's answer and check, does it equal the correct answer? That's kind of funky, but it's going to work. And so now we run this. What is 9 plus 2? Let's say we put 11. 9 plus 2 equals 11 is true. If we run it again, get a different set of 2 numbers. 2 plus 4, 6 is true. Let's put a wrong answer. 4 plus 1 is 7. And it will say 4 plus 1 equals 7 is false. Now, full disclosure, you would always do this problem using an if-else. This is not the way we would normally do this one. But, number 1, we haven't officially covered if-else. That's about to come. But number 2, it's good practice to see how do we print a true-false right here within this placeholder. Because until now in all of the formatted printing, we've always been printing a variable, right? But in fact, you can print multiple things. Like instead of putting here, what if I needed to print the correct answer? Hypothetically, if I wanted to print the correct answer there, I could have printed correct answer, or I could have printed num1 plus num2, which will give us the correct answer, right? So you can print more than just a single variable here. I'm going to go back to user answer. In fact, you can print, on this example, we asked Python to print the result of this Boolean expression. So hopefully that makes sense. And here is a solution provided here on the slides. A little bit different than what I showed, and that's okay. Actually, it's pretty similar to what I just showed. Great. So generating random numbers, we'll go through this quickly. I want to be cognizant of time. Check yourself. How do you generate a random number I such that I is between 0 and 20, inclusive of 0, but not 20? The answer is from 0 to 19. Random, not random, 0, 19, because the 0 and the 19 will be both included, and that's kind of what this said, from 0 up to 20, but not including 20. What about this one? From 10 to 20, now including 10, but again, not including 20, well, it's going to be random 10 to 19. This one, from 10 to 50, including both endpoints, it's going to be 10 to 50. Not too exciting because it's pretty straightforward. All right, officially covering an if statement. Python provides several different selection statements. This is what they're called. These selection statements, we have one-way if statements, we have two-way an if and else statement, then we have nested if statements and even multi-way if, elif, else statements. Finally, conditional expressions. We're going to be covering all of that throughout these videos. And we're going to start with a basic if statement. A basic Python one-way if statement is simply you take a path, you go down a pathway, and you execute maybe a series of statements if and only if the given condition is true. So if, and what follows the if is a Boolean expression followed by a semicolon. And if that Boolean expression is true, we will perform these statements. And notice that this has to be indented right here. And I will tell you it has to be indented exactly 4 spaces. You could use 2 spaces, you could use 12 spaces, but you'd have to, number 1, be consistent. But number 2, the Python style guide says use 4 spaces. You want to use 4 spaces. There's wisdoms for that. You're working with a team of people. Y'all are all developing in Python. You have to be consistent, and the easiest way is to follow the style guide. So notice, this is the first time we're seeing indentation. So if this Boolean expression is true, we need to indent all of those statements 4 spaces. And here is a flow chart showing what we just covered. If you have a Boolean expression, if it's true, you execute the statements, and then you proceed to the rest of the program. If that Boolean expression were false, you would skip those statements, they would not be executed, and then you would continue on afterwards. So revisiting that math learning tool, what can we do now instead of printing this true-false situation? Instead of doing that, we would like to give a more meaningful response to the user. Let's use an if statement and then print something more meaningful. And notice here I can print if the result is true, I can print correct, or otherwise I could print incorrect. So coming back to the code, I'm going to save this, and then I'm going to save as, and I want to call this version 2. And I would encourage any learner watching to do the same, so we can have 2 different programs, the original and now this updated version. So we have scanned their choice, we've scanned their answer, and now we need to print the results. So I'm going to say if user answer equals the correct answer. And so you know what? I'm going to take this correct answer here, and I'm going to put it just right above. We've determined the correct answer. Determine correct answer. By adding num1 and num2, saving it inside this variable correct answer. And so now I say if the user answer equals the correct answer, we're just going to print as was displayed, correct, great job. Print correct, great job. Super easy, right? Else, if it was not the correct answer, oh, we haven't covered else yet. Else is coming up very soon. We're going to improve this one with version 3. So if the user answer does not equal the correct answer, the purpose is just to practice. You would not use 2 if statements. You really should make this an if-else. We haven't officially covered if-else, so we're going to do it with 2 if statements. So if the result does not equal the correct answer, what am I going to print now? I'm going to print this statement incorrect. The correct answer is as follows. Incorrect. The correct answer is as follows. And then this print statement, I'm simply going to modify it. And because now, notice I want to print simply the answer. So I'm going to get rid of, I want to put something plus something equals something. So I'm going to get rid of this 4th curly bracket, and I'm going to get rid of this Boolean expression here. So I have 3 placeholders, and I have 3 variables that are going inside those placeholders. But this 3rd placeholder is no longer going to be the user answer. it needs to be correct answer. And so now if we run this code, what is 6 plus 9? 15, correct. Run it again. What is 2 plus 8? 10, correct. Let's do a wrong one. What is 2 plus 9? Let's say we have 12, incorrect. The correct answer is as follows. 2 plus 9 is 11. Cool. Program 3, even or odd. We're going to run through this and we're going to come back to revisit that last problem, as well as we're going to solve this even or odd problem in 2 different ways. So program 3, even or odd. Write a program to ask the user to enter an integer and then display if the number is even or if the number is odd. So always we need to think about our problem solving phase first. So number 1, we need to get a number from the user. That should be straightforward. But now how do we check if a number is even or odd? Just think about that. If I tell you 8 is even and you say, yeah, it is even, how do you know? Like what makes you know that 8's even? And you say, well, because it's even. And I tell you 11 is odd. You say, it is odd. How do you know? Oh, and so how do you actually articulate that something is even or odd? And so you might say, well, 8 is even because if we divide it by 2, it divides cleanly, you might say, or it has no remainder when we divide it by 2. And that is correct. When you divide by 2, and you check the remainder, and you see that there's no remainder, you know it's even. Otherwise, you know it's odd. And that's exactly what we can do with programming, because we've seen how do we check for remainder? We can use mod. So if we mod a given number by 2, and the result equals 0, and notice I say equals, the 2 equal signs, it actually equals 0, meaning there is no remainder, then we know it's even. Otherwise, if it's odd, we know it will not equal 0 and it will equal 1. And that's how we can check if a number is even or odd. And so here is the implementation. And I won't go code this one up, but you can pause the video and I would encourage you to code it. But this is using 2 individual if statements. I'm saying if num mod 2 equals 0, you entered an even number. And then we have a separate if statement. If num mod 2 equal 1, you entered an odd number. Now, I could have said if num mod 2 does not equal 0, you entered an odd number. Both of those would have been identical. For clarity, if I had just said num, we had num, right? Num equals 8. If num mod 2 does not equal 0, print num is odd. And this, of course, is not going to print num is odd because currently it's even, so nothing prints. If I run this code, nothing prints, and we should expect that. But if I make this odd all of a sudden, it will print num is odd because I'm dividing 7 by 2, and I'm checking, is the remainder not equal to 0, which is true. 7 divided by 2, it has a remainder, therefore it prints it's odd. I could have also checked equal 1. That's another way to check for odd. When I mod it by 2, does the remainder equal 1? Yeah, it does equal 1. So this is how we would have code to check for even or odd, but using a single path if statement. But now how can we update that? Using an if-else statement. So now we're finally getting to that intro trailer where we had an if and an else with that radius to get the area of a circle. So a one-way if statement, we only execute statements if it's true. But what about if it's not true? Would we like to take an alternative pathway? That's the idea of a two-way if-else statement. The syntax is if, and we have some Boolean expression, which will evaluate always to one of two things, either true or false. If this Boolean expression, and then inside that indented over, we're going to have the statements for that Boolean expression. If that's true, we do those statements, but if it's not true, else or otherwise, we do these statements. This is the idea of an if and an else, and here's the flow chart. If it's true, we perform this set of statements. If it's false, we perform this set of statements. And so now if we revisit that exact same program and we see, we can just change, instead of putting two independent if statements, previously we had, I come back to it, we had this, two independent if statements. We were checking the truth of this Boolean expression and then printing something conditionally based off of that truth. And then we had another independent if statement where we checked the truth of this Boolean expression and printed based off of the truth of that Boolean expression. That's two checks of the Boolean expressions, which is unnecessary. Here, we do one check. We check if this Boolean expression is true, we print it's even. But if that first Boolean expression was not true, we skip this print statement here, and we come to the else, and we print you entered an odd number. So revisiting this math problem, I'm going to hit Save As, and I'm going to call this a version 3. It's only a slight edit, a very slight edit, but instead of doing two independent if statements, it's absolutely better to put if else. So if the user answer is correct, perfect. Print correct, great job. Else we print incorrect, the correct answer is. And notice this space right here on line 15. I don't need that. I could have just gotten rid of the space. Sometimes you want a visual space. It was only for visual purposes. You could put the space there. You could choose to not put the space there. That's up to you. So look at that small change, and now we already have this great program. We've asked the user a math question, we've scanned their answer, and we've printed. If it's true, we printed the correct answer. We printed correct. If they got it wrong, we printed incorrect. And if you happen to notice the code here that I'm showing you on the slide, it's a little bit different than the code that I showed you live, which is great. So now you see two different solutions. So here I computed the correct answer, and I had the user answer, and I compared them. Versus here, I used a variable result. And what did I save inside that variable result, which is kind of unique, which is why I wanted to point this out. What did I save inside this variable result? Well, this is an assignment. Where should our eyes look when we have an assignment? Your eyes should look to the right. So when we look to the right, what do we see? We see number 1 plus number 2 equals answer. Well, what is that? Don't be confused. That's a Boolean expression. That's a Boolean expression. Number 1 plus number 2 equal answer. It's a Boolean expression, which is going to give you either true or false. So we're going to take that true or false and we're going to save it into result. And then I'm just checking, hey, if result is true, print correct, else print incorrect. So we have one more problem to do, and that's it. And this one problem is an additional math learning tool, and this one's on subtraction. Write a program to help a first grader practice subtraction. Your program should randomly generate two int values, both between 1 and 9. That sounds pretty similar. Here we say you should make sure that the first number is greater than or equal to the second number. That's different. Make sure the first number is greater than or equal to the second number, because we say that maybe the first graders are scared of negative numbers. If you ask them 7 minus 5 and they get 2, that's within their comfort zone. But on this storyline, if we ask them 5 minus 7, negative 2, it's like, and it rocks their world. They can't handle it, right? And they start maybe crying. So we want to practice, the real purpose is we want to practice simultaneous assignment where we swap two values, which we've done in a previous video. And that's the purpose really. So if these randomly generated numbers, if the first number is greater or equal to the second number, let's ask the subtraction question. But if it's not, let's swap them first. Then we prompt the user for the answer and we display the results. So the first part of the problem solving phase, already what we've done, we're going to use the rand int. We're going to use that function. We're going to use a one-way if statement to check if the first number is smaller than the second. If it is smaller, if num1 is smaller, we need to swap. So we're going to swap them using the simultaneous assignment. Then we're going to ask them the question, we're going to scan the result, and then print. We're going to scan their answer and then print the results. Pretty straightforward. So this is the output, and let's write a program to match this. So I'm going to, once again, save this, and I'm going to call this version 4, even though it's now subtraction. Version 4. Great, we generate two numbers. And what did I say is step 2 maybe swap the two numbers, the values, I'll say swap the two numbers if num1 is smaller than num2. Because we want num1 to not be smaller. They could be equal. We could ask them 5 minus 5. But we don't want to ask them 5 minus 8. We don't want the result to be negative, just that's the storyline of this problem. So if num1 is less than num2, that's a problem. What do? Swap them. How do we do swapping? If we recall, simultaneous assignment, super easy in Python. Num1, num2 equals num2, num1. Consider them now swapped. This swapping will only occur if num1 is less than num2. Great. Step 3, prompt the user to answer an or a subtraction question and scan their answer. So this is going to be negative, a minus sign now. Great. Print the results. So the correct answer is num1 minus num2. If user answer is correct answer, we print correct, great job. Else we print incorrect. The correct answer is as follows. This minus that equals this. So I think that already works. Let's check this. 5 minus 4. Let's put 1. Correct, great job. 4 minus 3. 1. Let's put a wrong answer. 1. We keep getting 1s. 1 minus 1. Let's put 0. I want to get something other than 1. Okay, 8 minus 5. That's 3. Let's do some wrong ones now. 4 minus 3. Let's put 2. Incorrect. The correct answer is 4 minus 3 equals 1. So that's great. I didn't ask them to please answer the following, or did I? No, I didn't ask them. I said, what is? So I could ask them that question. I could say, print, please answer the following, colon. That's a little nicer. And so I'm not going to ask them what is. I'll just put the, and I won't put a question mark either. Instead, I'll put a space and an equals. That looks more mathy. Please answer the following. 8 minus 1, 1. Correct, great job. Please answer the following. 7 minus 2, great job. Let's put some wrong answers. 7 minus 4, let's put 5. Incorrect. The correct answer is 7 minus 4 is 3. Let's do another wrong one. 8 minus 6, we'll put 4. Again, incorrect. All right. So that works nicely. Let's go. I was kind of worried there. No, I wasn't worried. That's an easy problem. Here's a solution on the slides. That's a fun one to code up. So hopefully you've coded up each and every one of these. Not too bad. Under an hour, almost 45 minutes. As always, reach out, ask questions, leave any comments, ask questions if you need anything. It's been fun. Take care.